Given to you is Q is a cube and the set of vertices are given by this set. Now you clearly understand that they're talking about a unit cube which looks like this, and one of its vertices is the origin, that is 0 comma 0 comma 0. Similarly, you can also try writing this one. Your x is 0 and your y and z coordinates are 1. Similarly, all the other vertices. Next, they are talking about f be a set of all the face diagonals, all the lines which contains the face diagonals. You can see clearly that there are six faces and each face has two diagonals. So f is collection of all such 12 lines. Similarly, they are defining the set S, set of all the four lines which contain the main diagonal. So S is, now who is main diagonal? The diagonals which are not the face diagonal are the main diagonal. For instance, if I join these 2 points, it is a main diagonal, or we also call it body diagonal. It passes across the body. Or for instance, if I join this point with this point, that is also a body diagonal. There are four of them, you can see here. Next, they are talking about if I take a line in the first set and I take another line in the second set, that means a line which is a face diagonal and another line which is a main diagonal, what is the max distance between the two lines? Now, if we look at the diagram, what do we see? That if I see this line that is a main diagonal and this line which is a face diagonal, can you see that they are meeting each other? And so the distance between them is 0. Similarly, I can try making another face diagonal, let's say this. Can you see distance between this body diagonal and this face diagonal is again 0, right? Now can I find another face diagonal which is different? For instance, if I look at this face diagonal and this body diagonal, they are not going to meet. They are skew lines, they are not going to meet. So there is a distance between them. That is what we have to find out. And you can also see logically the distance between these two lines would be the same as distance between this and this line, or rather distance between this and this line. So that means there are only two kind of distances. Either the distance is 0 or there is some distance. So we need to find out what is that some distance. So let's get started with that. How do we do that? If I have two skew lines, how do I find distance between two skew lines? We get a point on this first line, we get a point on the second line, and then we try finding a vector which is perpendicular to both of them. That is what we do. We try finding a vector which is perpendicular to both of them, both the lines, and then we just take the projection of this line which is joining a point on the first line and on the second line. We take projection of this line onto this vector. Now let's get started with that business. Let's name them. Let's say this is A and this is B, that's the face diagonal. This is O and let's say this is E, that's the body diagonal. Okay, now the face diagonal, let's say this is my A point and this is my B point. Okay, B point is given to you is 0 1 and 1. This is B, this is O, let's call it O because I know one point, and the easy point, the more easy our job is. Okay, O, and let's say some E is somewhere here. We don't care about that, right? Okay, now can you also tell me what is direction ratio of the line AB? Direction ratio of line AB, how do you get that? What is coordinate of A? Only z is 0, right? X is 1, y is 1, z is 0. Okay, so direction ratio of AB, what do you do? Component wise you subtract the coordinates. So 1 minus 0, that's 1. So direction ratio I get to be 1 0, and 0 minus 1, that's minus 1. Okay, this is the direction ratio of line AB. And can you also give me direction ratio of line OE? That is the main diagonal. Of course, what is E coordinate? 1 1 1, right? Yes. So 1 minus 0 1 minus 0 1 minus 0. So direction ratio of OE is 1 1 1. Now let's get this vector. Okay, shall we name them something? Maybe P and Q. Okay, so PQ vector we want. PQ vector is perpendicular to both of them. That means perpendicular to this as well as this. Okay, so what do we do? Cross product, right? So if I want to get the n vector which is perpendicular to both of them, I just do a cross product of both of them. So very simple cross product. It shouldn't take time. This. Okay, and what do we end up in getting? Let's see. This is 0 and minus minus is a plus, so 1 minus j, 1 minus, so you get a 2. Okay, and then plus k, again 1 and minus 0. So very easily you got the vector which is perpendicular to both of them is this. Can I get a unit vector out of this? Not a problem, right? You just divide by the modulus. And what is modulus of this vector? Under root of 1 square plus 2 square plus the coefficient square. Okay, so that's your unit vector. Done. Okay, now what is left with us? We need to get a projection, right? So what is projection of OB? Okay, what is vector OB? So if you want projection of OB onto this perpendicular vector, what do you do? Dot times this n hat. That's a unit vector. Okay, and what is my OB vector? Of course, B minus O, right? But it is same because this 0 0 0 0 minus 0 1 minus 0 1. So what is that? 0 1 1. That's my OB vector. And what is my n hat? This vector. Okay, let me write it in component form. 1 by root 6 comma minus 2 by root 6 comma 1 by root 6. Okay, the same vector n hat we have gotten here, and I'm writing it in component form. That's all. Now what is this value? Component wise you multiply, so you get minus 2 over root 6 plus 1 over root 6. You end up in getting minus 1 over root 6. Since we are looking for the distance, then we just take the modulus. Okay, we just don't care about the sign, we just take the modulus, and that is 1 over root 6. That is the distance between the skew lines, and that will definitely be this value which they are asking for. So this is your final answer. I will see you with another question soon. Bye bye.